Good afternoon. Welcome to ENT 304. My name is Matt Dreyer, and I'm joined by...
I'm Brian Graff. I'm a technical marketing manager for VMware Cloud on AWS at VMware.
We are so happy to be here. This is our second time back at the show presenting on VMware Cloud on AWS. This is a 300 level session, so you're going to see code. So before we go any further, how many of you have written code in the last couple of years? Excellent. We didn't want to get booed off the stage right off the get-go, so be prepared to see both poorly written code and in small fonts. So with that, thank you very much. Let's get started. So we started coming down this journey a couple of years ago, and it was really based on market demand, right? We've always kind of had two clouds, right? We've had the private cloud in your own data center, and we've had public cloud that's pretty much been in Amazon, right? And based on customer demand, what we finally decided to do was to start bringing those two worlds together. And so we call this hybrid cloud, we call this extension, we call this an actually very unique integration. And so when we bring the best of both worlds together, being all of the tooling and the automation that you've got in your on-prem data center, plus all of the power and the capability and the services that are available in the Amazon cloud, you really get something unique and differentiated. And we're going to actually demonstrate some of the power of this for you in the session today. So what we wanted to do is start by just showing a little bit about how the whole system works, and then really dive down into details on how the APIs work, and actually get into some Power CLI as well. So let's just take a look at what this thing looks like from a conceptual level, right? What we start with is the core virtualization stack from VMware. Our core virtualization stack runs in three separate capacities. We have compute virtualization with vSphere. We have storage virtualization with vSAN. And we have network virtualization with NSX. We take all three of these technologies, we run them on a bare metal server in Amazon, and instantiate an environment that is consistent with what you're running on-prem today. Many of our customers are running our latest release, 6.5. Our environment in VMware Cloud on AWS runs 6.6 code. Many of our customers in their own enterprises are already upgraded to these latest releases. And so we are very much consistent with that model. So you get the performance of bare metal, you get the consistency of VMware tooling, and you get an environment that is able to scale to the bounds of Amazon. So we started the service in the Amazon region of Oregon. On Tuesday of this week, we announced availability in Virginia. And as the roadmap works forward, we'll continue to announce in additional places. So we have this environment in the Amazon cloud. We then connect it back to your on-prem environment and give you a single pane of glass management through vCenter Server. This is very, very important because it leaves us with this operational continuity that our customers are really asking us for, right? I'm going to the cloud, but I don't want to retrain my staff. I want to keep things the way they are. I want to be able to move VMs in and out of the cloud without refactoring. And I want to be able to treat this as a contiguous environment through vCenter Server. So vCenter Server, somewhere in the range of 400,000 VMware customers have these. And so this is a huge footprint for us and something that we've got millions of administrators trained up and operating on every day. From there, we have this common API service from vCenter Server that can be consumed by the VMware vRealize suite, Power CLI, third-party tools, other SaaS offerings. And so we have no API change there at all. If it works with vCenter, it will work with VMware Cloud on AWS. Again, a very powerful proposition. But if that was just it, it would sort of look like a colo, right? It would sort of look like, I got some servers somewhere else, and it's sort of cloudy. This is where the magic of Amazon comes in. And so what we've been doing, and working in very close partnership with Amazon on, is to enable unique integrations with the Amazon substrate. And this really is joint development. And what we've been able to come up with is a set of capabilities that allow our services and our instances to talk very, very seamlessly to native Amazon services. So if you've got a VM running in VMware Cloud on AWS and you want to attach to an S3 bucket, not a problem. We can actually traverse an ENI into your VPC and hit that bucket. And maybe you've got a Redshift database that's also plumbed back into a VPC. Same sort of deal, smooth connection right across there. And we're going to show you some of these later on. And so bringing these worlds together and enabling new kinds of hybrid applications that are not only stretching from on-prem to the cloud, but from VMware Cloud on AWS to native Amazon services is something that is really exciting. So for those of you that haven't seen this yet, what I wanted to do is just give you a little tour of what our SDDC looks like. And so what we're going to do is we're going to log into VMware Cloud on AWS. We're going to see the SDDC that we have deployed there. We'll take a little bit of a look at the inventory, and then we'll come back out. The point that I want to make with this little video is to show you that even though we are operating in the Amazon cloud, the user has an experience that isn't entirely a VMware experience until we start doing the integration part. And so here we go. So I'm logged into VMware Cloud on AWS, and I've got an SDDC deployed here called TMM SDDC. This SDDC has 4 hosts in it, and you can see that we've got our credentials here to log into the vCenter server. The whole space here is very lightweight. Again, the point of the service is getting into the vCenter server and managing from that UI. And so you can see that we've got the handy links here to our API explorers, even the Power CLI connection string to come in. And we'll flip here for a second and show you the APIs that we're going to be using for the rest of this demonstration. All of this service is built on RESTful JSON with OAuth authentication. Our documentation is all done in Swagger. If you're building products, please build them with Swagger Docs. It makes everybody's life much, much happier. And so everything that you're going to see here is really built on top of these APIs. Okay, so let's start and go through the API stack a little bit and go through some of the key things that we've got here. Again, the whole thing is built brand new from the ground up. VMware has had a couple of other forays into the cloud. This was built from scratch, a whole new offering built on microservices. It's actually running in the Amazon cloud itself. This is all built through Jenkins pipelines and pops out the other end as Docker images. And so when we went around building this, we went after industry standards, right? If you're building a SaaS service that is not RESTful JSON with OAuth authentication, like you're not building the right thing. And you can kind of prove this over and over again, but we've basically taken industry standards and implemented them into our own. The other one that we use here, the UI that we expose is all Angular. And so you'll find that the design patterns that we've used here are very common. We have 3 different layers in our API stack, and each of these layers performs a very distinct function. And this is something that we're really looking to continue to isolate and make sure that we don't have things crossing the bounds. So at the top level, we have the console API, so console.cloud.vmware.com. This is where we do consumption of organizational level things. So things like instantiating an organization, managing users, paying bills, all of that sort of stuff happens up in that API space. If we move one layer below that, we come down into the VMware Cloud on AWS APIs. And these are all APIs dealing with your specific software-defined data center. So instantiating an SDDC, adding hosts to it, adding clusters to it, configuring the networking. That's all at the VMware Cloud on AWS API surface. And then the last API surface that we have is the vCenter API surface. And again, this is the one that has been around for a good long time. So again, if you've got existing automations and workflows that work against vCenter Server, we do those down at the vCenter level. This isolation of these 3 APIs is very important because again, if we start to get confused and do things like, well, create a VM from the console API, all of a sudden the world kind of starts going sideways on us. So we're being very clear and very clean in the way that we build out functionality. So these are 3 different services. We'll start and just kind of roll through each of these, and then we'll actually cut down in and take a little bit of a demo. So the console APIs, again, these are for sort of the highest level organizational operations that you might want to do. Actually, we'll take a look at the docs first. Most of these are available without a login. The ones that are, you're free to come in and we're happy to get you up and running with an account. And so you can start playing with these on your own. Again, these are all documented in a Swagger spec, and so they're nice and easy to consume. Okay, so, and again, we already kind of showed this, so we'll bounce forward. So that top layer API, the console API, does a couple of things. First, it's the place where you go get your authentication token. So everything that we do is done via OAuth tokens. So the first thing you need to do is go present a credential and come back with a token. From there on out, you continue to use that token in part of your header for all other requests that you do in the system. So with that token, you can do things like learning about the rest of the users in your organization, invite a user into an organization, remove a user from an organization, and in the future, we'll extend this to all of the billing properties. You know, view my bill, view my usage, and perhaps even pay my bill. Okay, so a little bit of pseudocode here. This is sort of like Python. It's not totally Python for those of you that are paying close attention, but it's close enough. So those of you that are familiar with RESTful APIs, this will look pretty clean. Essentially, we've already we've got an API key that we're using here. We're going to put that into a header request. We're going to go make an HTTP request against a specific endpoint. And then we're going to come back and enumerate the users in the organization with a print function. The print here would result in a JSON return of a dictionary full of all of the users and usernames here. Again, the real code is not much more complicated than this, but you can see this is a really nice way to operate with the environment. Show you the next level down. The next level down is the VMware Cloud on AWS service. The VMware Cloud on AWS service, again, exposes functions that are useful for SDDCs. And so the top level list of these are pretty simple. Create an SDDC. So this is the API that we use to instantiate that environment. If you hit that API with the properly formatted JSON request, we will come back in 2 hours with a fully deployed and running SDDC. So 2 hours when we come back with a 4-host cluster, vCenter servers stood up, NSX is all wired and running, everything is ready for you to log in. And again, you can automate this via the API. So we've got provision, destroy. We've also got the ability to add and remove hosts. Provision public IP addresses, and this will shortly be extended for performing all of the other network configuration, such as creating firewall rules, NAT rules, VPN tunnels, and likewise. Okay, show you again a little bit of sample code here. Again, we start with an authentication key, and we're going to go ahead and pass that key in as a request, and we'll then list out all of the SDDCs that are associated with an org. Again, you can start seeing how the URLs start chaining out here, and the structure is pretty nicely organized. So within your org, you have users. Within your org, you also have SDDCs, and all these things sort of chain out and enumerate. So you can kind of see there with the org ID highlighted. Okay, and finally, we'll take a look at the vCenter API. So the vCenter API has a long and interesting history. For a long time, it was entirely SOAP-based with XML returns, and so that was super cool about 15 years ago. And so as of late, we've been retrofitting this API and bringing it up as RESTful JSON. And you'll start seeing in here that this has already been well underway since the vSphere 6 release, and with vSphere 6.5, it's gotten really, really nice. And so from within this API footprint, again, there are a bunch of functions that you can perform. Some of them are interesting ones. You have to log in. Again, you have to authenticate to your vCenter. After you're authenticated to your vCenter, you can then do interesting things. List VMs, create VMs, destroy VMs, move them around, and that sort of thing. So again, we've got the 3 levels of Surface here. They're all RESTful. They all have a very similar feel in how the returns come back, and are pretty easy to use after experimenting with them just a little bit.
Here again is an example, and again you can sort of see the how the structure comes in. We're again making a call against the API endpoint. We're going into our specific org and our specific SDDC. We're then coming back and returning the username and the password for that entity. Then we use that username and password to go actually log into the vCenter server. After we're logged into the vCenter server, I'm going to flip the screen here. We can then create another request to go return the virtual machines out of the environment. So again, think of what we've done here. In this example, we've actually hit all three services. We logged into cloud.vmware.com to get our authentication token. We then went down into VMware Cloud and AWS to get the authentication credentials for vCenter server. And finally, we went into vCenter server and returned our inventory. Okay, so there we go. So let me back this up for 1 second and just show you a little bit about how this might work in the real world. So we're going to try this live, so wish me well. So we've written a little bit of Python code here. And I'm just going to exercise these. So this is the list of users that I have in my organization. Again, this is a total of about 50 lines of Python here from the whole thing. I can show my SDDCs. I can show my hosts, and now I'm going to start picking up pieces of the hosts in my SDDC. And I can even go all the way down and show the VM. So let me do one last command here. Feeling lucky here. So we'll go pull the virtual machines out of this guy. So there we go. We just dove all the way through those layers. We'll post this code out to VMware.com, the GitHub repository, if you want to bang around with it. But there you go. Very simple set of APIs. I had written code as a young child, and picked up Python about a year ago. And if I can do this, like you certainly can, and probably do it much better than I did. So what I want to do now is flip this over and go to another place that is even more fun and more near and dear to most sysadmins' heart. And so I'm going to bring Brian Graff up, and he's going to talk about PowerCLI and show you some actual real integrations.
Great. Thanks, Matt. All right. Kind of breathe a little bit, guys. We got a lot of code that came in. A lot of understanding. But now that we have that base understanding down, right, of the three different API planes, what I want to do is go through some real world demos. I've got about 5 or 6 demos I want to do from here, and I'll cross my fingers. I'll ask all of you to cross your fingers too that they work. Otherwise, this could end quite shortly. But I'll actually also have you guys interact with me for one of my demos. So stay tuned for that one. I'm going to actually have you help me do this. But what I want to do is, Matt showed us Python, right? Great code on how to hit those API planes. One of the things that I did growing up, because I am younger than some other people on stage with me, is I worked with Windows, right? And with Windows, we use a lot of PowerShell, right? So for a number of years as a sysadmin and an Exchange admin and BlackBerry Enterprise Server, all of that, we used a lot of PowerShell. Now, one of the great things is with AWS is AWS has a PowerShell module, okay? And there's like 1,400 commandlets, which can be overwhelming. But the cool thing is VMware also has PowerShell module for PowerCLI. So one of the great things here is we're talking about VMware Cloud on AWS. And people go, well, why do I care about running VMware in AWS versus some other cloud or some other colo or whatever it may be, right? One of the key differentiators is what we can do tying together with the AWS services, right? How many of you in here have used PowerCLI before? Or how many of you have stolen code off the internet to run to fix something in your environment? A lot of you are lying right now. I know most of us have. That's what we do, right? That's how we get through all this stuff, and that's perfectly fine. What I want to do is I want to tie together the PowerCLI code of VMware with the AWS PowerShell code to show you how we can go ahead and deploy and configure virtual machines on the VMware side and AWS services, obviously, on the AWS side. So First off, for anyone that wants to get started, there's two things that you need to do this, right? If you're running Windows, is to run this code at the bottom. Let's see if I can highlight it here. Okay, the install module -name AWS PowerShell. Okay, run that one as an administrator. It'll go ahead and install. Takes a couple minutes. The next one here is PowerCLI. Same type of thing, all right? Install module, name VMware.PowerCLI, hit yes, it'll go ahead and install. From there, you have full integration from one CLI into both stacks, okay? And that can be pretty powerful. So, how does this work? Well, I've got my cool little PowerCLI or PowerShell laptop over there on the left, and I've got up top, actually I'll just point this out here. Up top here, this is my VMware Cloud on AWS Software-Defined Data Center, and down below here is my regular AWS account. I've got VPCs in here. I'm guessing all of you, since you're here at reInvent, have VPCs that you're running things in, right? So I'm kind of just showing you what all we have. Obviously, the cloud in the middle is the internet. The line going between those is our connection into both from PowerShell. So that being said, who wants to see some live demos? Yeah? Okay, let's do this. So I wrote this code. Let's actually bring that up here. I'll show you the code first of what I did. And actually, I guess that kind of gives away the cool part of when I open this. But I went ahead and wrote some PowerShell. And what you'll see here is, I'll switch to the zoom here for you people in the back. Oh, maybe that's too zoomed. All right, I've got variables at the top. And those set out what I'm going to do. I'm going to create an RDS database, okay? And that's going to be named, let's change that now because today is not Monday, it's Wednesday. And we'll do 1. I've got a security group that I want to use for this. I've got the VPC where I want this to go. And I've got the code as I go through this of I want to deploy a MySQL database in RDS with certain username, password, and whatnot. Below that, I am then connecting into vCenter Server, my Cloud SDDC. So all of a sudden here, I've already done one call into Amazon to create the database. I'm sending in one call into VMware Stack to connect to vCenter Server. And then below that, I have some more variables that I'm using to point out where in my vCenter Server I want this to deploy. Okay? So I chose my reInvent resource pool, a workload data store. I've chosen several different template names. So what I'm going to do when I kick this off is I'm actually going to create the database. I'm going to deploy 3 different VMs. So let's think of this as a multi-tier application. And then we're going to see what happens. So as you can see some of this code here, I do have, it's about 168 lines of code, but a lot of that was to make this easier for you all to see. So with that being said, I'm going to go ahead and run this. All right, see, kind of cool. I spent, 20 minutes making that a little thing for everyone. So what this is doing is it's going ahead and it's deploying the RDS database. We get some of the information back. Like I said, we're now connecting into vCenter Server. It brings that back, and now it's deploying my VMs. Okay. It sits here. It's going to go ahead and deploy from template my Windows VM, my Ubuntu VM, and my Photon OS VM. Now, I can see that Photon's already deployed. Ubuntu is still deploying. The Windows one, this will take maybe 60 seconds. What I want you to think about here is how can I, thinking of yourselves, in my current environment, start leveraging this type of technology where I can connect both my VMware stack within VMware Cloud on AWS with my AWS services. I'm showing you RDS right now, but what else could I be doing with S3 or elastic load balancers or auto scaling? What other services can I all of a sudden leverage the best features of AWS with the best features of VMware? So as we can see here, I didn't get the progress bar working very well. You can see it says 0 of 100%, but you guys get what I'm doing. We'll give this a second, and actually while that's going, I'll flip over to vCenter. That's not the one. Okay, and as you can see here, we've deployed 2 virtual machines, and I'll talk you through kind of what this looks like. You can see I've got these nested resource pools, and within reInvent, here I've got my reInvent Photon, my reInvent Ubuntu, and my reInvent Windows machine. So we've got that up. Let's take a look here. You can see, oh, it still did Monday 10. I must not have changed the variable correctly. I didn't save it. I'm sorry, guys. So what that's doing now, if we go back and watch, is it's finished deploying all 3 VMs, and now it's checking the database status. So if we look again, I'm going to flip back. I'm sorry for flipping so much here. You can see that it's saying it's still creating that database. Once it finishes creating the database, it backs it up, and then we're good to go. So it's going to sit here until that's done, and then it can power on those VMs, and I can start using everything together. Kind of cool? Now, let's take a look at how this actually works. So we talk about integrations, but is this going over the internet? Is this going somehow between Amazon and VMware? How is that working? Let's take a look. So if I come in here and I click on Monday 10, we'll see a few different things. First off, okay, it's still creating, that's great. But we'll come down here to, I guess we can't see it till it's done creating. We'll go into the VMware Cloud side. There's 2 things that have to occur so that connectivity between your VMware stack and your AWS services can talk. Okay? The first thing is creating firewall rules in VMware Cloud on AWS. So I'm going to go into my SDDC here, and I'm going to go over here to the network tab. So in Matt's demo that he showed before, you could see that there were 4 hosts and the utilization. We're going to go into the network side. Now we've got a management gateway and a compute gateway. The management gateway is for all of your management virtual machines, your NSX machines, your vCenter server, everything that VMware runs that we don't want you guys to have to deal with, that's on us. And the compute gateway is where you put all of your workloads, okay? So for this to work, we're going to come down to the compute gateway where I'm putting my virtual machines, and there's 2 firewall rules that need to exist. Now I've got quite a few here, but what you're going to see is right here, the AWS inbound and AWS outbound. So with the AWS inbound, we're saying the source is any VPC that's connected to this account, and it's going to hit these management network segments that I've got. And then at the same time, we have an outbound here that says any traffic coming from these networks can go to my VPC. So essentially what we're doing is we're opening up a firewall rule between VMware's on the VMware side to talk to AWS. Now this leverages an ENI between your VPC and AWS and VMware Cloud on AWS. So this does not go over the internet. Okay, this is a high bandwidth, low latency connection that, as far as you're concerned, just works. Okay? So that being said, let's jump over to the Amazon side. And while that's still creating, I'll show you what we have here as far as what you need to configure. So if we go to VPC, you'll see each time you deploy an SDDC, you have to link it to a VPC in your own AWS account. So that's what I have here. And that's so that you can leverage these AWS services. So I have my TMM SDDC VPC. Now this VPC ends in 371F. What we're going to see here is if we go to our route tables, is that under the TMM SDDC, if we look at our routes, you can see all of these ENIs right in the middle. So we have an an internet gateway, but we also have ENIs that are doing that traffic between this account and my VMware stack. And all of the network segments here on the left are all networks within NSX in my VMware stack. When I create a new logical network, it automatically propagates and fills out the route tables here, so you don't have to worry about any of that. This just knows, and it will just do it for you. So the only other thing that we have to do to make sure that this works is to go and configure security group. So what we're doing here is we're saying that this security group, here we go, is we set some inbound and outbound rules, okay? So as you can see here, I have all traffic for these internal network segments on the VMware side. And what I've said is any of this traffic coming from the VMware stack can come in to the security group. And at the same time, outbound rules, I've set all traffic to 0.0.0. This can send out anywhere, but I also, just to show you here how this would work if we didn't let all traffic go out to the entire internet, is the fact that I've got this one internal network in my VMware stack that I'm saying these guys can talk. With me? Yes? Hand up if you're with me. Okay. So, can we keep the questions for the end? Sorry, what I want to do, I've got a number of demos. I know there's going to be questions. We're going to cut this about 10 minutes short, and anyone that wants to do Q&A afterwards, we'll cut the video and we'll do the Q&A. All right, so let's see here. If we just click on this one more time and see if it's done. That's backing up. All right, well, while that's doing that, you get the picture. So I'm going to ask for some help. Is that where I'm at? All right. Actually, I'm not going to ask for help yet. Matt, do you want to come back up and do a couple of your demos first? Got carried away.
Okay, so we're gonna flip back and go through another little demo here. And this is the first of two that we'll show in this environment. The idea here is that there's a whole bunch of really cool tooling that we can leverage within the Amazon portfolio to really make lives much simpler as a system administrator. How many of you are still making VMs by hand? People making VMs by hand? Wouldn't it be nice if you had a crazy little web form where people could just make their own darn VMs? And so that was the idea here. And so built out a tiny little application. This application is a single HTML file sitting in an S3 bucket. That S3 bucket has been enabled such that it's serving this as a static website. When a user comes in and selects a VM, we then go through a Cognito and hit a Lambda function. The Lambda function is running a little bit of Python code that's going to go take the user request and kick off the creation of a VM in the VMware Cloud on AWS SDDC. Again, not a whole lot of code in here, but pretty interesting functionality. So we'll take a look. So here's our little website. It's called makeavm.s3 website US. You can see I've got 4 different choices here. These are 4 different items that I have in my content library in my vCenter server. We'll look at the source code here, and really what I want you to focus on is how simple this is. We have the UUIDs of these 3 content library items loaded up into our form. So these are each mapped back to a type of VM that we're going to deploy. If we come down a little bit, you can see that we're just using the standard Amazon Cognito JavaScript library. And you can see the Lambda function that we're actually going to hit called create a VM. So we pass through Cognito to give ourselves some more protection on the Lambda side, and then fire away. So now we'll cut over and we'll take a look at the Python code. So the Lambda function here is called VM Request-O-Matic. That function is actually running this little snippet of Python code. And so we'll flip, and you can see here that we're just going to take the user input. We populate a little bit more of a profile around the virtual machine that we're going to create, including giving it the name that the user specified. You'd of course want to sanitize that if you do this for real. And then when we pop back, we'll actually present the user back with a link to the VM after it's created. I didn't record that part of the demo, but you can kind of see it happening here. So Alan Smith, Alan at VMware.com, is going to pick a Windows 10 VM. We'll then flip over to vCenter Server, and you can see that this starts to run. So we go and fire off the deployment out of Content Library, start building the virtual machine, and within just a couple of minutes, this thing will be deployed and ready to hand back to our user. So not too bad. The code, you can see, was not horrific at all. In total, this is maybe a couple hundred lines, and massively useful. Right? If you can automate, please do so. It will save you many, many years off your life. Okay, so the next one I wanted to show is another kind of interesting capability, the daily report. So the idea here is, wouldn't it be nice if every day we could go pull the inventory out of the SDDC and take that inventory and stick it back on a Slack channel. And again, this is all in the cloud, so why not? Funny backstory about this, I actually wrote this code during a meeting that I was not very interested in attending, so this took me about an hour to do.
And that included figuring out the Slack API, which was massively easy to use. So here's how this is going to work. CloudWatch events are like cron jobs. You can set them up to fire at a particular frequency. So all I'm having to do is on like a daily cadence, go hit my Lambda function. The Lambda function is going to log into my environment, go ask vCenter for the inventory, take that inventory, package it up as a little JSON request, and send it out to my Slack channel. And again, we'll just sort of walk through here. So we start off with the CloudWatch event. CloudWatch, we've got a cleverly named event here called cron, because again, I'm old. And so my cron job is simply going to do one thing, and that is go run my Lambda function every once in a while. And so there we go. We're going to just go ahead Lambda underscore handler, which is pretty generic because that's the default one you get. And so this one's actually going to go hit that endpoint every 5 minutes. The Lambda handler is running a piece of code. Again, Python because it's simple and easy. And you can take a look at what we're doing here. So we go run a function called getInventory. So we go log into our vCenter server, set up a couple of variables to count both the powered on and the powered off VMs. Again, we're using the REST endpoint on vCenter server to go harvest this. We then come down and populate a couple of arrays and get ready to send the response back. The other nice thing about this is that we can do this all within a couple of functions. We go grab the requests, do a little bit of math on the data store, and then hit another function that's going to post this back to Slack. Again, you're going to start seeing the same sort of a design pattern. Posting to Slack really means just doing another RESTful post back to another endpoint and sending over the contents of our inventory. From there, I'm going to flip over to the Slack channel and show you what this looks like. So in Slack, Slack also has a very wonderful extensible interface. So I've created a new application on Slack. My application is, again, sort of one line of code, and it's called handle webhook. And so all this application is doing is listening for an inbound webhook. So when it receives that inbound webhook, all it's going to do is take the contents of that, do not even a little bit of formatting, it's just going to take the contents and post it into the channel. So here's my application. The setting is receive a webhook and post to channel. And so you can see this in action then. As soon as the CloudWatch event hits, it goes and fires this whole sequence. And you can see the information coming back into the channel. So again, very simple, very easy to use, and kind of, again, shows some interaction between this environment and the rest of the Amazon Services portfolio. All right, so let me get off stage here, and we'll flip back and show some more on the other side.
Great. If any of you guys notice here, the timestamp for this report, he was burning the midnight oil before 12:37 a.m. All right, so we deployed the multi-tier application with an RDS database already in just a script of PowerShell, right? What I want to do now is I want to do the same thing, but leverage an Apache web server sitting in VMware, the VMware stack, while doing a web server, or sorry, a database server in RDS, and we're going to leverage your help with this. Now, what we see here, though, is it is using this ENI going between your own VPC, right? This is where the AWS services run, and your VMware Cloud on AWS SDC account. So this VM is going to allow us to do some cool things. So what we have here is we've set up a public IP. So this is in the VMware Cloud portal. And we have a few different public IPs that I've requested, okay? This comes in directly from AWS. We've used this, and I've created the firewall rules and the NAT rules to point to my front-end VMs so that we can hit those front-end web VMs, right, from the internet. So that being said, we're going to jump over here to this one called Lychee. Now, this one, I've already got the front-end set up. It just needs the database connections. So from the security groups that you guys saw, right, we had the security group set up to take my networking from the VMware side and allow data to pass through across that ENI. So all we need to do at this point is to add in the information from the RDS instance. So if we go to photo album here, we can come down and grab our endpoint name. We'll put that in here, put in our username and password for the database, and then the database name itself, I believe, is a little further down, name photos. Okay, so this is where I need your help. Oh, I didn't change it. Just kidding, I won't need your help. Anyways, it can see though, as you can see here, it's actually made that connectivity. What it's saying is that I didn't go in and chmod or chown the folder where you guys would help me here and post pictures. Anyways, since we haven't done that, we'll switch over here to this one. So if you guys see, I've got 52.43.6.239. Now I don't have that set up to a domain name, but as you can see in the VMware Cloud on AWS console, okay, we have our front-end VMs. I've gotten this public IP address. The natting all works because when I hit this IP address, it brings me here. And I have it stopped here at SuiteCRM. This is just the front end. It hasn't been connected to the database yet. So it's as easy as setting up the security groups and the firewall rules. And we're going to go ahead here, and it's going to give me a red error saying I didn't add in an email address, and that's fine. Now, to see if this works, we'll take the database name. So we'll do the same thing just for the other database that I have here. Reinvent. We'll grab the endpoint name. Okay. And we'll grab the database name, SuiteCRM. Okay. We'll just put in a few little passwords here so that it lets us go. And I'll use Matt's email address for here. You can spam him. Oh man, this is what happens when we do demos. There we go, wrong password. All right, so it's going to give us a few errors as it's going along, and that's just because of the PHP of this freeware that I'm using. But as soon as it finishes here in about 10 seconds, we'll be able to click next. We'll be able to go to the admin portal, open it up, and log in. So all of a sudden, what we've done now is we've leveraged RDS. So now I no longer have to be the one to take snapshots, upgrade my SQL server, do any of that from a VMware standpoint, right? We just said, you know what, it's easier for me to throw this database over into RDS so I can leverage the benefits of RDS, but I'm going to keep my front end over here. So I can click next. It brings me back to the login, and we'll just try this out and see if it lets us log in. Okay, and then I can scroll down past the PHP issues that are not an issue with this connection, and we've got our SuiteCRM. Kind of cool? So all of a sudden now, what can you do in your own companies leveraging a connection like this? So what if we did the reverse? I don't have a demo of that one, but let's think through this. Maybe I have a database cluster sitting in my environment on the VMware stack, and I want to leave my databases there, but I want to leverage elastic load balancing and auto-scaling for my front end. So all of a sudden, can we take this, leverage the VMware console, setting up the firewall rules for the connectivity between this and your VPC, and then put all of your front-end servers in EC2 and have the connection go the reverse way. All of a sudden, I'm still leveraging DRS, HA, the VMware scheduler, over-provisioning, thin provisioning. We can leverage all of that still for my databases, right? But I can then also leverage auto-scaling and elastic load balancer so I can scale up and down my front end when I need to. Okay? Now, let's do some other fun ones here. All right, so I have I gotta turn on my tether here. Thanks to a kind soul that's in attendance here. They helped me set this up because the Wi-Fi does not actually allow for BG connections, and that's what an IoT button does. So I have an IoT button here, and what we're going to do is with a single click, we're going to go ahead and leverage the IoT button a Lambda function, okay? It's going to call out, it's going to create 5 virtual machines in my VMware environment. And let's do that. So I'm going to run a script. Now what this is doing is I'm actually running a PowerShell script that is sitting here watching the Simple Queue service, SQS. And what that's going to do is if I click this button, let's see if it'll connect and go green. Okay, it went green. It's going to sit here and it's going to query the SQS for a message to come through. And when it comes through and it sees that I've done a short press, then we'll switch back over to vCenter and see what happens. Now, is this very practical? Okay, this may not be something that you do in your environment. Okay, it says short press and it's cloning out 5 VMs. So if I come over here, we can see that those VMs are cloning and they're showing up here somewhere. Here they are, they're down below. All right, IoT Photon. So maybe this isn't practical, but what I want to do is get you thinking of how can I leverage all these services together. Now, if this is a demo environment or a dev test environment, right? Can I easily just click a button and have it grab a Jenkins job or grab one of my latest builds and deploy everything for me? So I want to go out and get some coffee with my buddies. I click my button once here, I walk out, it deploys all this for me, and I come back and I'm good to go. So I'm going to hold it down now, do a long hold. Okay. It's going to connect in, hopefully go green, goes green. And what that's going to do is once it catches up in the SQS, it's going to say, for every single time that I click this, so the last time I did this demo, I clicked it like 16 times. I just gave it to my 3-year-old and said, click this, right? So we had whatever 16 plus times 5 is. It's more than I need to count. And then I did a long click, and it went through and it cleaned up all of those virtual machines that I deployed out. Okay? So as easily as I created this, it's going to go through and delete. Okay? So you can see it just barely finished that task, and we can see here that those virtual machines are gone. Now, here's one that's a little more applicable. Okay? I have this thing called vcheck. How many of you have heard of the script called vcheck? Okay? For those of you that don't know what it is, vcheck is a free script that will go out and query your VMware environment. It'll go through, I think there's like 100 and something different modules that it'll run through. It'll give you an entire just inventory and report on what's going on in your environment. Okay? So this is a community project, but if I double click this, what I'm going to do is I'm actually going to run vcheck against my VMware environment. So it's hitting the SQS, it's going to run through, it's going to do the query into vCenter, and figure out what all I've got going on. I think I dropped it down to 30 or 40 modules just for the sake of time. And then once it's finished, it's going to pop up the HTML report on my screen, but it's also going to make a copy of that, shoot it up to an S3 bucket, make it public, and send me an SMS to my phone, which I'll turn on the sound here and I'll hold it up so you guys can see when it comes in of that report. So from 2 clicks of the button here, I'm now running through doing an entire check on my VMware environment, leveraging AWS services, Power CLI, and the VMware APIs, and it's being sent to my phone when it's finished. Okay? Pretty cool? All right. So let's let this run through and think. So maybe you don't have 15 IoT buttons sitting on your desk with sticky notes labeling what each button does, but at least this gives you an idea of what you can do. Now, I guess I'll hold on to my phone so that when this finishes, you guys can see what comes up. And I apologize, last time I did this demo, I had a way to hook it into my machine so you could see my phone screen up here, but it just didn't work out this time. So what am I now, Matt? Like 75% of my demo is actually working? We'll see. We'll see if this one finishes here. So 55 of 59. We'll let it keep going. And as this goes, once again, think, how can I leverage all these different services for the best of both worlds? Okay, there it is. Okay, it came through. Now, you can't really see it, but I can click on the button, and for those of you in the front row, when I open it up, it will look the same as what you see up there. Okay? I'll put up this code for anyone that wants to do it and somehow, explain to their spouse or significant other why they need to justify a purchase of an IoT button. So instead of flipping back and forth slides, I went ahead and just did all these for the sake of time. But this is the one we just did. So kind of understanding what went on, right? This is a little easier to understand. We went ahead and clicked the IoT button. It went ahead and I didn't change the generic. Dang, that got away from me. It calls a Lambda function, which then goes to the simple queue service and sends a message. From there, my PowerShell laptop is picking that up, queries my VMware environment, and then shoots out left the report to the S3 bucket, changes that file to be public, and then sends an SNS, or sends a message to SNS, which sends a message to SMS, which sends it to my phone. Okay, pretty cool. I enjoyed doing that one. That, to me, was one of the best parts of VMware Cloud on AWS. So don't tweet that's the best part, but to me, that was pretty significant. All right, and with that, I'm going to turn this over to Matt to come up and do some Alexa love.
All right, so we got one last thing to show you. And so buttons are fun, Python's fun, but the funnest thing of all is having somebody to talk to. And now you can create your own. And so what we've done is we've built, again in Python, some code that goes and queries our SDDC and allows us to interact with it with voice. And so we've got a little bit of audio here, so let's see if we can get this thing to go.
Ask VMware Cloud about my cloud data centers.
Let's try that again.
Ask VMware Cloud about my cloud data centers.
You have 3 cloud data centers. Their names are Ireland_VMC, Virginia_VMC, Oregon_VMC.
Ask VMware Cloud for details on Virginia_VMC.
The data center Virginia_VMC has 8 hosts. Its operational state is running, and it is at 87% capacity.
Tell VMware Cloud to add 5 hosts to Virginia_VMC.
I just added 5 hosts to Cloud Data Center Virginia_VMC.
And there you go. So thank you so much for your time this afternoon. We'll be taking some questions afterwards. We will get all of this code out onto our GitHub repository. Thank you very much, and enjoy the rest of your show.